Fine. Next data type we'll see is an character data type. This character will occupy only 1 byte. So whenever we declare here character of ch in a random access memory, the ch variable will occupy only 1 byte. And inside the ch, you can store any character of the keyboard. Let's take here, if you want, you can store an alphabet, can be done by giving ch is equals to alphabet A. Not only alphabet, you can store even digits. You can give ch is equals to 5. You can store space by giving ch is equals to space. Okay, just open a single quotes, one space, and then close the single. All this character data has to be enclosed within this single quotes. Let's see what actually stored inside this character. So I said here it's occupying here 1 byte. Okay, so and 1 byte is nothing but an 8 bits. Now why it is occupying 1 byte? Okay, what is the reason for occupying an 1 byte? Now here what happens is when I give a ch is equals to alphabet A, inside ch actually A is not stored, a value something called as 65 gets stored here. So when I give a ch is equals to lowercase a, instead of 65 it stores here 97. Okay. So what is this 65? What is this 97? This is all are nothing but ASCII code. ASCII stands for American Standard Code for Information Interchange. American Standard Code for Information Interchange. Okay. So every character of the keyboard has a code. It may be any character. So if you take an uppercase alphabet A, it's having a code called as 65. If you take an B, it's having in 66. C, it's an 67. This goes up to Z. A Z, you have an ASCII code as a 90. Same if you take an lowercase a, it is having an 97. Okay, lowercase b is going to be 98, lowercase c is going to be 99. So like that, if you take an lowercase z, this goes up to 122. Okay, take an 0. 0, when you type, actually the code transferred is going to be nothing but 48. If it is 1, it's nothing but 49. 2 is going to be 50. So this goes up to 9. So up to 9, it's going to be nothing but 57. Every character, you take a blank space, you can take a plus symbol, minus, every character is having a code. Even an enter key. This, when you press enter key, that code, ASCII code is nothing but 13. Okay. So these all are nothing but ASCII code, American Standard Code for Information Interchange. So this ASCII code is actually made up of 7 bits, not an 8-bit. Okay. So it's made up of 7 bits. That's why when you give a ch is equals to alphabet A, internally it is going to be taken as an ch is equals to 65. Okay, you might have given here ch is equals to alphabet A enclosed within single quotes, but internally it will be taken as an ch equals to 65. That means inside the ch variable 65 will be stored, not an alphabet A. So that means almost it is similar to an integer. Okay. If you want, you can declare a character variable by giving a character ch, and then instead of giving alphabet A, you can also give here ch is equals to 65. This is also valid. That means if you give a ch is equals to 65, means you have stored an alphabet A. Okay. Now total 8 bits have been allocated for character. Of that, 7 bits will be used as data bits, and the last bit again will be used as a sign bit. That means inside a character, the ASCII value can range from 2 raised to 7, that is nothing but 128. That means the ASCII value ranges from minus 128 to plus 127. So inside a character, you can store an ASCII code which is ranging from minus 128 to plus 127. Okay. So any arithmetical operations what you perform for an integer, any operation on an integer what you perform, the same all operations can also be performed on a character. The only difference between character and integer is character will occupy 1 byte, whereas integer will occupy 2 bytes. That is the only difference. Character value ranges from minus 128 to plus 127, whereas integer value ranges from minus 32,768 to plus 32,767. That is the main difference between char and int. If you want, you can declare an integer variable x, and you can also give your x is equals to alphabet A. You can give your x is equals to alphabet A. So inside that integer variable where 2 bytes has been allocated, you will be having the value as 65. Same way, you can declare a character variable ch, and then you can give your ch is equals to 65 rather than giving ch is equals to alphabet. You can also perform an arithmetical operation, as I said you, that is, you can give a ch plus plus. When you give ch plus plus, after incrementation, the ch value is going to be 66. That means it's having an alphabet B here. So any arithmetical operations can be performed. Okay? So if you want to find the sum of two numbers, it can also be done. It may be two numbers of integer type. It can also be done through character variable. So I'll just write a small code to find the sum of two numbers. Fine. This is how the program looks. Usually we do find the sum of two integer values. Then usually what we do is we declare an integer variable here by giving int a comma b comma c. Okay, and then we give a is equals to 10 and b is equals to 20, and then we'll give a c is equals to a plus, and then display the result here by giving printf percentage d, that is an c. The same code can be done by declaring instead of as an integer, you can declare this of type character here. So you can give your character a comma b comma c, and this whole code works fine, perfectly works fine. So inside a you're storing 10, inside b you're storing 20, and then c is equals to a plus b. C will be having 30, and here because you have given a percentage d, that c is integer representation, that is an ASCII code. Whatever the value is there, it will treat it as an ASCII code. The 30 will be displayed. So that means there is no difference between int and char. Both are same. Only difference is the range of value you can store, because character is occupying only 1 byte, whereas integer is occupying